In this lesson, we're going to be looking at graphing inequalities, which conveniently enough really are adding only one extra layer, maybe two depending on how you look at it, to just graphing an equation. So as long as you can graph the equation, you'll find that you can graph the inequality. So here's an equation to go ahead and graph. This is something we've looked at already this year. And so you should be able to look at that equation and first of all know what the shape of the graph is. I see the absolute value bars are in the equation. Therefore, I know that it's going to be a V-shaped graph. And the fact that we have the x minus 5 with the minus 5 on the inside of the parentheses like that tells me that it's going to be moving at 5 units in the x direction. Specifically, minus, remember, moves it to the right 5. And then the minus 3 hanging on the end, it's not inside with x, so it's going to be moving it up and down. Specifically, a minus there moves it down 3. So I'm going to go right 5, down 3, and that's going to be the first point, the vertex of my V-shaped graph that I'm then going to draw in from there. Now that I've drawn that in, I have my basic graph then of y equals the absolute value of x minus 5 minus 3. But now, I did say we're talking about graphing inequalities today. So what if I changed it just a little bit and instead made the equation this? It's no longer y equals, it's now y is less than or equal to. What does that change in our graph? Well, whenever we graph an inequality like this, we need to be able to figure out basically which side of the graph am I going to be shading on. And so as an early way to be able to tell here, we know that it has to be everything either on one side of the graph or on the other. So if I knew one point either worked or didn't work, I could know that everything else on the same side was the same. So let's actually just try a point. And I'm going to try a nice little easy point. I'm just going to grab the point right here at 0, 0, because it seems like a nice, easy number to try out here. So I'm going to take that number, that coordinate pair, and I'm going to plug it in there into my inequality. If I do that, then it becomes 0 is less than or equal to the absolute value of 0 minus 5 minus 3. And I'm going to look to see what that equals. So the 0 just stays a 0. Then I have the absolute value of negative 5 minus 3. And then I have 0 is less than or equal to, the absolute value of negative 5 is 5. So that'd be 5 minus 3. And 5 minus 3 is 2. So is 0 less than or equal to 2? Yes, it is. And therefore, that means that this point right here at 0, 0 should be shaded. And if that one point should be shaded, then every other point on that side should also be shaded. And so then if I know that point is shaded, go ahead and shade everything on that same side of our graph. And as you do that, you'll notice then that we are shading everything that is below this graph. And that is actually a rule that we can extend out to be even broader than just this one problem, because it turns out that any time you see a less than symbol or a less than or equal to symbol, that's going to tell you to shade your graph below. Now, if this symbol were instead a greater than symbol or a greater than or equal to symbol, then that would mean that you'd be shading above it. So it kind of works the way you might think it would. Less than means shade below, greater than means shade above. The trick is just remembering, of course, what we call it, whether we call it less than or greater than, and remembering that we're shading either above or below. It's not left or right of it, it's above or below. So then if we then extend that, we can then see on this particular inequality, it's the same basic equation, except this time I've written my inequality by making it a less than instead of a less than or equal to. So what does that change about the graph? Because remember, the last time it was a less than or equal to. Well, the difference is not going to be in the shading. Both less than and less than or equal to are going to shade below. The difference is that when something's less than, it means that it cannot be equal, which means that all of the points that are on those lines that I have drawn there, the ones that are exactly on those lines, won't work. And so for that reason, instead of drawing nice solid lines there, we draw them as dotted lines. So if it is either a less than or a greater than, you use a dotted graph, not a solid graph. That way you're showing that everything that's on that line, because they're right on the border, is not included. Now beyond that, we still do need to shade, and this is a less than, so yes, once again, we are going to shade our graph below. So then that would be our final graph for y is less than the absolute value of x minus 5 minus 3. Now in our next problem, now we're dealing with something where we have to do the whole thing from scratch. Now, first of all, you'll notice that it's y is greater than or equal to. The fact that it's or equal to tells me that it's going to be a solid graph. And the greater than tells me that I'm going to be shading it above it. However, I still need a graph there in order to be able to make it. So I'm going to look at my equation. So first of all, I notice in my equation that this is a cubed function. And whenever we're graphing a cube, we're going to end up actually graphing something that looks like that. To be a bit more precise, this would be the shape of our parent function, just plain old x cubed here. All right, so now I want to do the normal transformations that I would to that graph. And you notice here is x plus 2 cubed. Remember, the plus 2 sitting inside of the parentheses means it's going to be moving it to the right 2. So I'm going to take my graph and I'm going to be moving it to the right 2 units. And then the plus 4, it's hanging on the end. So that tells me that I'm going to be shifting the entire graph up 4 units. And so then that ends up being my graph. Of course, I might need to extend it out a little bit here on the end, but still, there I have my basic graph. Now, once I have the graph, remember, it's going to be solid. Okay, so I don't need to go back and make it dotted or anything like that. But I do need a shade above it because, again, it is a greater than or equal to symbol, and greater than always means shaded above. And so this would then end up being my shading. Now you'll notice that as I take a look at this graph, that I even have shading like over here, even though I don't see the graph. But I do know that the graph does keep going down, and it keeps going to the left as it heads down this direction. And so even though I don't see it on my graph, I do know that it does continue down there. And so I do continue shading above, even if I can't see it because it is there. And then on our final problem here, notice that this one is y is greater than. Okay, so first of all, it's greater than, which tells me that we're going to be shading it above. And notice it's just greater than. It's not greater than or equal to, which means that I'm going to be making my graph dashed or dotted. And so I'm keeping that in mind about what this is doing to it. But the rest of it over here, the 2 times the square root of x minus 6 plus 1, that gets graphed the same way as it would as if it were just an equation, except that I'm going to try to remember to make it a dotted line as I make it instead of a solid line. Now, in order to do that, I need to remember what a square root graph is shaped like, and the square root graph is the one that is shaped like this. It actually starts at a particular point, and then it is going up and to the right from there, and that first point is here at 0, 0. The next point I need to go through is 1, 1, and then after that I would go through 4, 2, because the square root of 4 is 2. The next number I can take the square root of is at 9. That's 3, so I'm going to go through the point 9, 3 as well. And remember, I'm wanting to make this a dashed graph here. And so I'm going to draw my curve in, but I'm going to do it dashed. A way that you can do this on your paper is that when you're drawing it in, you could even draw it in solid, but then take your eraser and erase little hash marks into it that way as well. All right, now I got a couple other things going on in this one. First of all, I do have a couple shifts, and usually when I'm graphing, I like to think about those shifts first. So you may well have actually started by making your graph over to the right 6, because the x minus 6 is going to move it to the right 6, and then up 1. But you'll notice that we also have that 2 in there. And that 2 is going to stretch our graph to be up twice as high. So I'm still going to start at the same place. So I'm still starting right 6 and up 1, except instead of just going over 1 up 1, I'm going to go over 1 and I'm going to go up twice as far. I'm going to go up 2. And instead of over 4 and up 2, I'm going to go over 4 and up twice as far. So I'm going to go over 4 and up 2. And so then this is going to be my graph for my square root, or at least as much of it as I can see on my particular graphing grid at the moment. So remember, I made it dashed because it was a greater than, not greater than or equal to. I also now need to do my shading, and it's a greater than, which we said means that we're going to be shading it above. Okay, so I can go ahead and just start shading it above, right? But this one is going to inspire a particular question to come up. Because what happens at this point? Should I have any graph over to the left of that first point or not? And the answer is actually going to be no. There should not be anything over there. So we're actually going to leave that empty because there's no graph to the left of this first point for it to be above. And if there's nothing for it to be above, then we can't shade above it. And so for a graph like this, where it simply does not exist for part of it, you do not shade above or below any time where the graph does not exist. And so with that, this graph is then done. We made our dash graph and we shaded above, so that's all there is to it.